Hello everyone. So the title of my poster is the Quantum Mechanical Insights into Heterogeneous Surface Reactions During Chemical Vapor Infiltration. This is Atal Bhowmik and I'm a master's student in the Mechanical Engineering Department at UTC. During CVI, which is Chemical Vapor Infiltration, that is a process that is used to make stronger materials. Chemical vapor infiltration is very important, and our research work is very important and crucial because this can be applied in different industries like automobile, space industries, semiconductor, nuclear plants, and other. Wherever we need to make our materials stronger and wherever we need to send our materials to an extreme environmental condition like extreme temperature and extreme heat, extreme pressure, we need to make it robust and stronger. CVI is the process that can be used to make things stronger, and by doing this it can be helpful to find a viable solution to the current engineering problems in nanotechnology. And this process is carried out from methyl trichlorosilane that involves a series of surface reactions, heterogeneous and homogeneous, and then finally it is used to deposit silicon carbide layer on any substrate surface that is used to make any material withstand in severe temperature, pressure and heat. In our research, we identify the steps of MTS decomposition into silicon carbide. During this decomposition process, the reaction mechanism is divided into heterogeneous reactions and homogeneous reactions. So the most challenging part is the heterogeneous reactions, where the gas species is react with surface species and eventually it creates silicon components and carbon components, which is finally turns into silicon carbide layer. The silicon deposition is way more than clear based on the previous literature and previous research work, but the most challenging part is the carbon deposition, and the carbon deposition part is making the total process slow and expensive. So we are working on identifying the reaction mechanism, the reaction pathway of carbon deposition on the surface during chemical vapor infiltration. Among a set of surface reactions, we identified so far two reactions which are responsible for carbon deposition on the surface. They're involving C2H4, and that C2H4 molecule is reacting with silicon carbide and then creates carbon molecules on the surface, and it also creates methane gas, which is a byproduct and further involves in the surface reactions later part of the mechanism. We used density functional theory based Vienna Ab initio simulation package or VASP, and we used a software package called Media. And using the VASP parameters, like VASP is a tool that used to calculate the quantum mechanical calculations. It solves the Schrodinger's equation and it uses a different potential and functional. Using a certain set of VASP parameters, we can calculate the transition state, which is in fact useful to find the activation energy barrier for any reaction. And then by vibrational frequency calculation, we can identify the rate constants of the reaction, and then finally we used Arrhenius equation and Eyring equation to find a Arrhenius fit for the reaction rates against the different temperatures, and from that plot we can identify the activation energy barrier again. So these three things, like first we solve the reaction step by step from initial structure through transition state structure, and finally we got the final structure, like the product of the reaction. And then we calculated the energy barrier of that reaction, and then we calculated the reaction rate, and from that reaction rate we find the Arrhenius fit. By these we can say this reaction is following this reaction mechanism and this reaction path, and then we can predict the reaction, we can predict how much time it will take to deposit carbon on the surface, and then we can say this is our complete mechanism, and this reaction step is the rate limiting step of chemical vapor infiltration. So we are still working on the other reactions. We only presented one reactions here that is very crucial during chemical vapor infiltration for carbon deposition, and in our future studies we will focus on other reactions as well. Thank you for listening. Bye.